Solving quadratics factoring part 2 is the more significantly challenging ones. This is the one you really want to be quiet, calm down, and pay attention, because yesterday it was mainly Friday or whatever was mainly taking out the GCF and setting those equal to 0, or it already had the GCF set up for you. There was a couple of real factoring, but this is where we're going to go ahead and do more roof-topping and more regular factoring, which by the likes of the last test you guys are not proficient on. So you need to continue to practice factoring. Factoring does not go away. It does not. It's one thing it'll show up in every single class throughout high school. So, and then into college. So you need to be prepared for that. All right, so the first example is 33x squared equals negative 22x. Anytime you want to solve a quadratic, you got to set it equal to 0. So the first thing I need to do is do what?
Add 22.
Yeah, I need to add 22x to both sides. Okay, that'll cancel this out here, leaving me with that 0 that I'm looking for on the right side. What's on my left side? 33. I heard it. 33. X squared plus 22x. Why don't I add? They're not like terms. For those of you guys trying to make it 55x squared, some of you guys are multiplying, trying to make it 66 wouldn't have been multiplying, but I see where you're going with that. But again, they're not like terms, so we don't add those together. Okay, so the next thing is to look automatically for your what? GCF. In this case, we have a GCF. It is what? 11x. So 11x comes out of our parentheses. What's left? 33x squared divided by 11x is 3x. 22x divided by 11x is plus 2. And that all equals 0. Can I do anything else to either one of my two factors? No. So what do I do now? What do I do now? 11x equals 0. And what's the other one? 3x plus 2 equals 0. Okay, so to solve the 11x equals 0, I'd simply divide both sides by 11. So x is equal to 11. I'm sorry, 0. And then over here I do what? Just solve for x. I'm going to subtract 2 from both sides, leaving me with 3x is equal to negative 2. And then I'm going to do what? Divide both sides by 3. So x is equal to negative 2/3. If I was to write this in a solution set, I would end up with negative 2/3, comma 0. And that would be my final answer. And again, that's more along the lines of the part 1 stuff, just to kind of get you started. Okay, any questions on that? Okay, let's look at our next example. Our next example is n squared minus 9n is equal to negative 18. Step 1 is to add 18 to both sides because I want to set it equal to what? 0. So that gives me n squared minus 9n plus 18. I didn't add 18 to anything but the end because they're not like terms. 18s cancel out, leaving me with nothing on that side, so I have to put a placeholder of 0. You guys, here's the deal. When we're doing these kind of lectures, from time to time, I will call you individually. Okay? At this point in the class period, we don't have time for me to sit here and make sure everybody understands because you guys wasted about 15 minutes of class today. Okay? If we are going too fast for somebody or somebody is lost, do not be afraid to raise your hand and say, hey, I have a question. Hey, I don't understand that. Okay? Because I'm going to tell you right now, if anybody says anything to you, they will be in trouble, first of all. And secondly, we need to make sure you understand before you leave this classroom today. If you don't understand, or I don't answer your question adequately enough, and you walk out of this class confused, you need to show up after school pass to make sure you understand this. You cannot continue, some of you cannot continue to walk out of this classroom each day not knowing what we're doing. Okay? All right, now I have n squared minus 9n equals 8. So there's no GCF. So then our next step is to go ahead and drop your parentheses. Why?
No coefficient.
No coefficient in front of the n squared term. Okay, so then what?
Drop down to 2 in.
Drop down an n in each parentheses. Then what? Factors of 18 that equal -9. And you said -6 and -3. That would be correct. Okay, so then I do what with these? I put them in here, and I have -6 and -3. Now what? N minus 6 equals 0, n minus 3 equals 0. So n equals 6, n equals 3. If I put it in a solution set, I have 3, 6. Now it's shortcut, or not shortcut, I mean mental math, obviously. When you have n minus 6 and n minus 3, okay, it's just the opposite number, right? Take this -6, make it positive. Take this -3, make it positive. Mental math, okay? Any questions on that? Okay, let's look at our third example. 5x squared plus 3x minus 2 equals 0. So 5x squared plus 3x minus 2 is equal to 0. Okay, do I need to solve for 0? No, because it's already done, right? It's already equal to 0, so I don't have to set anything equal to 0. Next step would be to find the GCF. Okay, there is no GCF, so our next step is to rooftop. Why am I rooftopping this? That's wrong. Say it again. Because it has a coefficient. I think you said because it doesn't. Because it has a coefficient. Since it has a coefficient, we rooftop. So 5 times -2 is -10. Okay. So I need to find factors of -10 that equal what?
Oh, -10.
That equal what? 3. Okay.
-2 and 5.
So -2 and 5. So -2 times 5 is -10. 5 minus 2 essentially is +3. So that works. So what do I do now?
Put those in.
So how do I rewrite my next line? 5x squared minus 2x plus 5x minus 2 equals 0. We don't put the parentheses on until we rewrite it as a whole. Okay, now go ahead and close your parentheses, or put your parentheses on. It's called grouping. The reason we don't group it until we have them all is because you cannot group things if there's only 3. So we need to verify that we did make sure we had 4. Okay? Now, greatest common factor, GCF, in the first parentheses is x. That leaves me with minus 2. What about the next one? 1. Very good. A little hint, a little red flag. If this, when you're done with this, looks like this already, there's a great chance that your only GCF is 1. And the 1 has to come out. It has to. Some of you guys made that mistake on a homework assignment before, but it has to come out. You've got to have it to go with something else. So that 1 comes out, leaving you with 5x minus 2, right? So nothing changed in that set right here because I pulled a 1 out. Yes? Yes. That's right. Sure. Bye. Okay. So, now, what's my next step?
Take the 5x minus 2.
Take both of your GCFs.
Take your GCS first. And the reason I like to take it first is because I kind of blocked this one out, which is a good thing. So I take my GCS, and that comes what? X plus 1. And then I bring down my other one, which is 5x minus 2 equals 0. Now what? X plus 1 equals 0, and 5x minus 2 equals 0. Okay? And then I have x equals negative 1. That's the easy one. What do I do over here? Add 2 to both sides. Okay, leaving me with 5x equals 2. Divide by 5. So x equals 2/5. So if I put it in a solution set, I have negative 1 comma 2/5. And there's my answer. Okay? Always remember that even if there's nothing on this, when you're doing these, okay, now if you're looking for the initial GCF, the very beginning of your problem, if 1's the only answer, you don't take that out. But when you're in the middle of a problem and you've already taken a GCF out of 1, and you're doing the rooftop method, you have to pull the 1 out and use it. Everybody follow that? Okay. Yes?
Doing this is necessary to write x minus negative 1. We just put x minus 1.
What?
Because x equals negative 1.
Yeah, sorry. No, that's x equals. Is that what you're saying? Okay, moving on. Now we have 75r squared minus 48 equals 0. Okay, do we have a GCF? Okay, what is it? Huh? 3. Okay, so she said we have a GCF of 3. So I pull the 3 out. What's left? 75 divided by 3 is? 25r squared. 48 divided by 3 is? What? Negative 16. Okay. Equals 0. Okay. This 3 is just going to keep tagging along. Now, what do you notice here?
It's a binomial.
Okay, yeah, it's a binomial.
And they're perfect squares.
They're perfect squares, so we call that what?
Special product.
Difference of squares. Good job. Difference of squares. That's our special product, right? So the difference of squares. Okay, so who remembers the difference of squares? Shortcut.
Isn't there a squared minus b squared?
No, somebody was saying it. No, not A equals. It's A.
A plus b.
A plus B times
A minus b.
A minus B. Okay, so here I'm going to have 3 comes down. What's A? 5R. Very good. What's B?
4. Negative is 4.
So plus 4, and then the other, and it doesn't matter. You could have done negative 4 first if you want to. And then the other one is 5R minus 4 equals 0, and that's the shortcut method. Okay. If we have time, we'll come back and look at this problem again using the long method. Okay. Now what do I do?
5r or 3 5r plus 4 equals 0. 5r plus 4 minus 4.
Okay, Luke, go ahead. You're confusing me. Huh?
How do you know something is perfect square?
Because if you can square root it in your calculator, it's like 5 times 5 is a perfect square.
Oh,
Remember what you learned like in 5th, 6th, 7th grade, something like that? Those perfect squares.
alright.
All right, so what do I do now? I have 3 sets of factors. What do I do? And you might have been saying the right thing, but the way you said it didn't make sense to me. What do I do with all my factors? Okay, so start. Tell me what I write. 3 equals 0. Is that logical? No, that's gone. That doesn't have any relevance to this problem. But do it so you know what you're supposed to do with your factors. Okay, now what?
5r plus 4 equals 0.
Okay, and then?
5r minus 4.
Okay, now.
Yeah, that's what I was saying.
Okay. Okay, now do what? Subtract 4 from both sides. That gives us 5r equals negative 4. Then divide by 5. I heard it. R equals negative 4/5. Okay. Okay, then add 4 to both sides. That gives you 5r is equal to 4. Now what? Again, divide by 5. So r is equal to 4/5. So essentially what you end up with is 1 positive, 1 negative. Wouldn't that make sense?
Yeah.
Why does that make sense?
Because both your equations are the same except for the one side.
Yeah, your equations are the same except for the positive and the negative sign. Yes, ma'am.
Are you supposed to write 3 equals 0?
I just said do it out of practice because it is a factor, right? So you said all your factors equal 0. This is just what this does. And again, this is algebra 1. It's more of a application math. In geometry, it's more of a analytical math. And so what this does is prove that you understand this is a factor. 3 equals 0 isn't logical, so you can't solve that as a root. Okay? And remember, these are what? What are these called again? These problems that we're doing? They're quadratics. Quadratics have how many answers?
2.
Or?
1.
1 or
0.
0. Can they ever have 3?
No.
No. Okay, this is just proving that there's no way that there's a third answer. Okay? Okay. Our next example. We have 100d minus 4d cubed equals 0. So 100d
2D or 4.
minus 4d cubed is equal to 0. GCF? 4d. That gives us 25 minus d squared equals 0. Okay, what do you notice this time?
25 is the perfect square.
25 is a perfect square and
D squared.
d squared is a perfect square. Quick update, quick notice. Anytime this number is divisible by 2, an exponent is divisible by 2, it's a perfect square. So d to the 4th would be a perfect square as well. You'll learn more about that in algebra 2. But d to the 4th is a perfect square, d to the 6th is a perfect square, because you square root an exponent by dividing it by 2. Okay, and we'll talk. You'll learn more about that in algebra 2. Okay, so this is a perfect square. Okay, so we have 4d times what?
D
5
plus
plus
5.
D.
Okay, 5 plus d times
5 minus D.
5 minus d.
Wait, that would equal negative 25. Oh, no, never mind.
Okay, equals 0. Okay, now can I solve this?
Yeah.
Okay, so I end up with what? 4d equals 0. Do what?
You said we don't, that's useless.
No, that's not useless. Divide by 4, and I'm going to tell you why in a second. She would write notes like that. That'd throw me off. Contradict what I just said. D equals 0. Okay, then we have 5 plus d equals 0, so d equals negative 5. And then we have
D equals positive 5.
d, okay, sorry, no, you're right. 5 minus d,
Why are we getting 3 answers?
hang on, I told you I would talk about that in a second. 5 minus d equals 0, which is d. You have negative d equals
Negative 5.
negative 5, and then positive d is equal to positive 5. Okay, now, yes, we have 3 solutions. 0, negative 5, positive 5. Now, here's why. What kind of problem is this one? Is this a quadratic?
No.
Look at the original problem. Is it a quadratic?
No.
No. The original problem has a what?
A cube.
A cube. This tells you how many solutions you're going to have. Okay? So this is 3. You're going to have 3 solutions.
Okay.
Now, this right here is what? This one little part right here.
Perfect.
This is a quadratic.
Quadrant, yeah.
So this has 2 solutions. So there's where all 3 of them come from.
I'm confused about this right here. This side.
This?
The right side. Yeah, all of that. I don't.
5 minus d equals 0. Solve for d. Subtract 5 from both sides. I didn't write it
So
down.
we had 5 plus d equals 0.
Okay, let's go back. Whoops. This is my bad. I just skipped steps. I shouldn't have done that. Okay, so in order to solve for d, I'm going to subtract 5 from both sides. That's going to cancel, leaving me with d equals 0 minus 5 is negative 5. Follow that?
That's you not writing anything down.
What?
Oh, never mind. Never mind.
Okay. Are you good? Okay, over here. Solving for d still, I'm going to subtract 5 from both sides, just like before.
Oh, because we had. Oh, okay.
And now it's negative d equals negative 5. And then d equals positive 5. Okay. Any other questions on that? Okay, last but not least, you have 4a squared equals 20a minus 25. What do I do first? You could subtract 4a squared from both sides. I like to keep my a squared positive. So what can I do instead? 4a squared minus 20. So I'm going to subtract 20a from both sides. Equals negative 25. Now what? So then I'm going to add 25 to both sides. So then I end up with 4a squared minus 20a plus 25 is equal to 0.
So does the 0 always need to be on the right?
Doesn't always have to be. I like to keep my a squared. I like my first term to be positive. Okay? So, next step. Next step. No. Nope. GCF. What's our GCF? Does 4 go into 25? No, so 1, so there is no GCF. So now rooftop. When I rooftop, I get 100. Okay? So then I end up with, what two factors of 100 equal 20? Negative 20.
Negative 10 and negative 10.
Okay, negative 10 times negative 10, right? This is actually a perfect square trinomial, which we're not going to do right now. So I have 4a squared minus 10a minus 10a plus 25 equals 0. Group. Greatest common factor in the first set? 2a, leaving me with 2a minus 5. Greatest common factor in the second? Negative 5, thank you. Okay, leaving me with 2a minus 5 equals 0. So then I have 2a minus 5 equals 0 and 2a minus 5 equals 0. I only have to do this once. This is what you call a double root. Okay, a double root. So it's only actually one root. This is our one solution problem right here. This is how you get one solution. Because now I need to add 5 to both sides. That leaves me with 2a is equal to 5. Divide both sides by 2. Hang on one second. Hang on one second. A is equal to 5 halves. Okay, it's at the very bottom, but it's 5 halves. That's one root. It's called a double root. Okay, so that's it. That's all of the notes from part 2. Here's your homework. Get it on your way out. See ya.